So this is the topic of opcode fetch timing diagram. Okay, and first of all, you must understand, what do you understand by opcode? Opcode means a binary equivalent of an instruction. Okay, an instruction is what the microprocessor understands as commands that it can do. Okay, so opcode is a binary equivalent that the machine or the microprocessor understands, the language of the microprocessor, binary language. Okay, so there are three things related to opcode. First of all, the address. Where is it located? First of all, in the 8086, it is located in the code segment. In the 8085, it is located anywhere within the 64 kilobyte of memory. Okay, so the code segment. So instructions are placed in the memory one after another. पहिलो instruction, let us say 2005 मा छ भने दोस्रो instruction 2006 मा, तेस्रो instruction 2007 मा, चौथो instruction 2007 मा, पाँचौं instruction 2008 मा, and so on. So the instructions are placed sequentially inside the memory, inside the code segment of the 8086 and inside anywhere in the 8085. Okay. अब त्यही इन्स्ट्रक्सनलाई मेमोरी अर्थात र्यामबाट उठाएर माइक्रोप्रोसेसरको इन्स्ट्रक्सन रजिस्टरमा प्लेस गर्ने कामलाई हामी अपकोड फेच भन्छौँ। त्यो एउटा के भयो, एउटा एक्टिभिटी भयो, एउटा मसिन साइकल। हाउ मेनी मसिन साइकल्स डज अपकोड फेच टेक? प्लिज रिमेम्बर, अपकोड फेच गर्दैमा इन्स्ट्रक्सन कम्प्लिट भएको छैन। इन्स्ट्रक्सन कम्प्लिट भएको छैन, यो त भर्खर सुरुवात हो। इन्स्ट्रक्सनलाई हामीले बोकेर कहाँ ल्याएको छौँ? माइक्रोप्रोसेसर भित्र लिएर आएको छ। अहिले इन्स्ट्रक्सन एक्जिक्युट पनि भएको छैन। सो सुरुवाती जुन अपकोड फेच इन्स्ट्रक्सनलाई बोकेर माइक्रोप्रोसेसरसम्म ल्याउनु पर्ने काम छ, त्यसले कति मसिन साइकल्स खान्छ, त्यो हाम्रो टपिक अफ इन्ट्रेस्ट हो। ओके, यू कैन सी T1, T2, T3, T4 over. These are the T states or clock cycles. These are the T states or the clock cycles. Okay, one T state is equal to one time period of the clock signal. One time period of the clock signal. You can easily notice it from the from your you can see this is one time period starting from here and ending over here. I am coloring this yellow, highlighting this yellow to indicate one time period. Okay, so one time period is one T cycle. There are several T cycles and we have named that T1, T2, T3, T4 and so on. Okay, now what happens in the first T cycle or the T state? Okay, first of all, to read anything from the memory, the address must be provided. The address must be provided so that the particular memory location where the instruction is placed can be selected. Okay, so what is the address? The address is written over here, 2005. The address is written over here, 2005. You can see over here. This is the address. Okay, and that has been written over here. And the higher part of this address is, let us say, this is the higher byte. I will highlight this yellow, and this is the lower byte, which is let us say I am coloring it this blue. So 20 is the higher byte, 05 is the lower byte, and that's why you know the memory is a 16. The memory address is a 16-bit address. 16-bit address, and what happens is that the 16-bit address goes through two parts of the address bus. The lower bus is 87 till 80, which is multiplexed with the data bus, and the higher bus is A8 till A15, which is standalone. So in A18 till A15, I will highlight that it is carrying 20 over here. 20 has been written over here to indicate that this crossover over here, this crossover event, please pay attention. This crossover event is actually a data exchange event. At this point, what you can say that a new data is transferred. new data is transferred. Okay, so this is the point that we need to see. This event, I will highlight this event, and up to here I will highlight it over here. This event is event number 1. I will write that event number 1. Okay, and this event is I will label it event number 1. Address appears in address bus. Okay. This is event number 1. Okay, I will write over here like this. Address appears in address bus. Okay, so it is in 2 parts. Address appears in address bus. This is event number 1. It is in 2 parts. One is in address lines AD0 till AD7, which is multiplexed, and the other is, please note, it is here. हामीले सुरुदेखि नै भनिरहेको छौं माइक्रोप्रोसेसरमा डाटा र एड्रेस सँगसँगै कहिले आएको हुँदैन. Okay, how do we recognize this? How do we recognize that it is that this multiplex lines is actually carrying data. Okay, this multiplex line is actually carrying data or memory. This multiplexed lines, okay, it is actually carrying what? Address. Why? Because this is bus. You see, because of this presence of this strobe signal. What is a strobe signal? A strobe signal is a short-lived pulse. Pulse भनेको के हो? एकचोटि मात्रै आउने सिग्नललाई हामी के भन्छौं? Pulse signal भन्छौं. So a strobe signal is a single pulse. A strobe signal is a single pulse. So this ALE is active high strobe signal. Active high strobe signal. What do you mean by this? Yeah, active high means when it is 1, it is active. When it is 0, it means nothing else. It means nothing. So it is active means it is indicating that the address is available on the address bus, address data bus, or I will highlight this on these pins, Okay. So ALE1 हुनुले के जनाउँछ त एड्रेस आइरहेको छ भनेर जनाउँछ. Okay, and at the same time these are the status pins. I will not talk about these status pins. IO/memory, okay, IO/memory S1 and S0. What I must tell over here that at this point this pin, this control signal IO/memory is equal to 0, as indicated over here. Why? Because if this had been 1, actually this would be fetching data from an IO device. So because the instructions are placed or the opcode is in the memory, that's why it is actually opcode fetch is a memory access, So hence IO/M should be equal to 0. So these are the 3 things related to address appearing in the address bus. Number 1, ALE is equal to 1. Number 2, IO/M is equal to 0. And number 3, data exchange or value 2005 appearing in A05 appearing in AD7 till AD0 and 20 appearing till A8 till A50. Now you might asking why is it 2005? Because that is the address of the instruction. Okay, that is the address of the instruction. So this is the first event over here. Up to here. I will drag this. Yes. So, okay, this is the first instruction. Okay, next, this is what happens in T1 clock cycle. If you were to write it, okay, or if you want to tabulate it in the T1 clock cycle, you could write 3 things. Okay, in T1 clock cycle, you would write 3 things. Okay, number 1 ALE becomes 1, number 2 IO/M becomes 0, and number 3 address appears on the address bus. This are the 3 events that occur in T1 clock cycle. Now next comes T2. T2 मा के हुन्छ भन्दाखेरि अब एड्रेस आइसक्यो, एड्रेस दिने काम सकिसक्यो हैन, जुन मेमोरी लोकेसनलाई सिलेक्ट गर्नुपर्ने थियो त्यो मेमोरी लोकेसन सिलेक्ट भइसक्यो है। अब के गर्ने त, मेमोरी लोकेसन सिलेक्ट भइसक्यो भने अब नाउ वी आर रेडी टु रिड डाटा or read the opcode from that particular memory location. Okay, so in this clock cycle a read signal is generated. See over here, a read signal is generated. This is the second event. Okay, this is the second event, and I will. Okay, this is the second event. Okay, and okay, sorry. Opcode read start. So here what we have started, we have started reading the opcode. We have started reading the opcode, and I will place it somewhere over here. I should label it number 2, event number 2 in your teacher. Opcode read start from this point onwards. So you can see over here that the read signal is an active low signal. अघि जस्तै ALE थियो त्यो active high signal थियो, read जुन छ त्यो active low signals, active low signals. So you can see over here that read goes low to indicate that the read operation has started. Okay, read operation has started. So and whatever is being read, that is data, so that will appear on the data bus. So at this point an exchange of data occurs over here. You can see the crossover over there. You can see the crossover over there. This crossover indicates that this is an exchange of data. So at this point we have an exchange of data and opcode appears over. What is the opcode? The opcode is 4FH, which is a binary equivalent of move data from A to C, or move from A to C, register A to register C. So this is the instruction, move from register A to register C, and the binary equivalent or the opcode for that is 4FH. 4FH. Some people might be figuring out what is 4FH. So basically I will write that in binary. I will write that in binary. Binary. For FH is basically 1000. Here you for Vaina 0100. Right? That is 4. And what is F? F is 1111. Okay. This is 1111. Okay. So I will make it smaller and I will place it just near here. Okay. So this is your 4FH or 01001111, which is the binary equivalent of move CA, or the machine equivalent of move CA, or the opcode for move CA. Okay, and move CA is the instruction. Okay, the instruction means that you want to move data from register A to register C. Okay, so this is the second event, opcode register. Now read will take some certain time. Read will take certain time. Okay, why? Because you have to access the memory, and then you have to start reading. Every device that is included is a logic circuit, so it takes, there are some gate delays associated with read, and hence read will take some time. So you can see that the read signal stays on for the second clock cycle as well. So for the 2 T states, the read continues. Read continues in the third T state as well, or T3. Okay, read continues. And finally, when the read signal goes when the read signal goes high back once again, okay, then what you might say that read is complete now. So this is the point when read is complete in the third T state. I will. This is the third event where read is complete. Read is complete. Okay, and I will also label this. Okay, bye. Event 3, read complete. So opcode fetch is basically taking how much time? It is taking 3 clock cycles or 3 T states. 3 T states. And you must remember that throughout the duration of the read, throughout the duration of the read, the memory or the address that had been provided must stay on the address bus, So you can see that is okay for A8 till A15. A8 till A15, the address remains there for the entire T1, T2 and T3 T states. But on AD0 till AD7, okay, the address remains there for only T1 state. In T2 and T3, the address is replaced by the opcode, which is 4FH. So if the address should remain there throughout the duration of read, this does not look good over here. Okay, this does not look to be true over here. So what is basically happening is that the AD0 till AD7 is a latched bus. Okay, that's why address latch enable. There is a latch over there. So whenever ALE goes back low, the previous address gets latched into the address bus until a new address appears from a new ALE. So latch को काम के हो भन्दाखेरि जबसम्म त्यो ALE आउँदैन तबसम्म त्यो latchले के गर्छ त त्यो एड्रेसलाई आफ्नै रेजिस्टरमा सेभ गरेर राख्छ, त्यो बफरहरुमा सेभ गरेर राख्छ. So that means the address is latched over there, hence replacing the address by the opcode in the T2 state still does not change the address in the address bus, and hence throughout the read duration, that means T1, T2, T3 duration, the address remains on the address bus. Okay, understood? Understood. So this is about opcode fetch. This is just the first part of an instruction. You have just fetched the instruction from the memory to the instruction register. Okay, and you have done nothing about it yet. Okay, now let us move forward. Now memory read timing diagram.